Hi, my name is Sara Egemose and I'm from University of Southern Denmark. My talk will be about Lake Nordborg, which is situated in Denmark and which has been treated with aluminium. The lake is situated in the southern part of Denmark on the island Als. It's 55 hectares and it has a catchment area of around 1,200 hectares, which consists of primarily urban areas and agricultural areas. The lake is a high alkaline lake and it has been eutrophic for several decades. The lake is suffering from both external and internal phosphorus loading. This is the P-balance for Lake Nordborg from 2002, showing that in the upper 10 centimeter of the sediment, there are about 3.5 tons of mobile P. Each summer from May to September, around 1/3 of this, corresponding to around 1.3 tons, is released to the lake water, causing low thacky depth and high algae production. But as most of the water is running through the lake in the winter period and not in the summer period, only 35 kilo is removed from the lake on a yearly basis, indicating that the natural recovery of the lake will either never happen or take very many years. Therefore, it was decided to restore Lake Nordborg in 2006. The aim was to reduce the external P load by 30% and to eliminate the internal P load by adding aluminum to the lake water. The aim was a future phosphorus concentration below 100 micrograms per liter and an increased second depth. The external P load was reduced by establishing 2 precipitation ponds with integrated sand filters to treat some of the water coming into the lake and to trap some of the phosphorus in the water. One was built in the agricultural area and one was built in the urban area. A third inlet was redirected so that instead of running into the lake, it's now running directly into the outlet from the lake. The internal P load was reduced by adding polyaluminium chloride. The dose was 52 grams of aluminium per square meter and all depth above 2 meters was treated. The dose was calculated relatively to the mobile P content in the sediment and the ratio between aluminum and phosphorus was 8. The addition of aluminum caused big changes in the sediment P release. We had studied 2 stations before treatment in 2006, and especially in the summer months, we saw high release rates of phosphorus from the sediment. Whereas after the treatment in 2007, 2009, and 2010, this phosphorus release was almost eliminated. The reduction was 90 to 94%. The addition of aluminum, of course, also caused big changes in the lake water phosphorus concentration. Looking first into total P, which is the black line, we had concentration as a summer mean before treatment in 2006 of around 240 micrograms per liter. Whereas after treatment in 2007, 8, and 9, we had concentrations as summer mean between 26 and 65 micrograms per liter, corresponding to a reduction of 73%. The pattern was the same for the dissolved inorganic P, where we had a summer mean concentration of a little less than 200 micrograms per liter before treatment, whereas after treatment we had concentrations between 5 and 9 micrograms per liter. The external P load was reduced by 40% from a little less than 600 kilos in 2006 to 350 kilos in 2007. And the new annual average inlet concentration was around 117 micrograms per liter. The internal P-load was reduced to 103 kilos per year. Earlier, we had more than 1 ton per year. The P-sedimentation rate was reduced, and we now, in 2007, had a positive P-retention in the lake. Also, the pore water P concentration was heavily affected. Actually, it was reduced by 99% because the released phosphate was now trapped by the aluminum in the sediment. But it was not only the phosphorus cycle that changed, also nitrogen was affected. The nitrogen concentration in the water changed. The year after, in 2007, we saw an increased concentration of both nitrate and total N in the lake water, whereas the concentration of ammonium decreased. The increase in nitrate can be due to two factors. One was that we saw a 21% higher external nitrogen load in 2007 compared to 2006. And the higher concentration can also be due to that the algae production is now heavily phosphorus limited due to the very, very low phosphate concentrations in the lake water. The decreased concentration of ammonium is primarily due to a decrease in the release of ammonium from the sediment, as indicated here, where we again have investigated the release rates on two different stations. In 2006, before treatment, we see that especially in the summer months, we have a big release of ammonium from the sediment into the lake water, whereas after treatment in 2007 and 2009, this release is reduced by 79 to 83%. There might be several reasons for this decrease in the ammonium release. We saw that the oxygen consumption rate decreased by 51 to 91%. So there was simply a lower consumption of oxygen in the sediment. That might lead to a higher nitrification rate due to these better oxygen conditions, or a decreased ammonification because the mineralization in the sediment is now P limited. But what about the water quality? The aim, as I said in the beginning of the talk, was a lower phosphorus concentration, but also a higher Secchi depth. The 2 first years after treatment, we saw a higher Secchi depth. Especially the first year after, we had around 1 meter higher Secchi depth calculated as a summer average. Whereas 3 years after, we had a very low summer average Secchi depth, actually also lower than what we saw in 2006 before treatment. We of course also studied chlorophyll A, but we couldn't see any significant changes from 2006 to 2007. So the reduction in phosphorus concentration was not sufficient to induce a shift in the chlorophyll A concentration in the lake. Also, the fish population was studied, and we saw a rapid change in both community structure and habitat distribution. The fishes started to move from being in the more shallow water to the more deeper water. We saw that the population of perch increased, whereas the population of roach decreased. The reasons are several, but the main reasons are probably more oxygen in the water, meaning that the fishes are able to stay in deeper waters. There are less turbidity, and the enhanced predation on the roach also forces them to go into deeper waters. Another thing that we observed after the aluminum treatment of Lake Nordborg was that the fresh aluminium flock seems to be focused in the deeper parts. We studied 3 different stations in the lake before treatment, 1 month before treatment, 1 month after treatment, and 1 year after, and 4 years after. The 3 studied stations were the deepest station, which is around 8 meters, a station of around 7 meters, but which also has resuspension, and then a station around 5 meters. And what we saw was that already 1 month after treatment, some of the aluminum flock has moved from the more shallow stations into the deep station, so that we now have a much higher content of aluminum in the deep station compared to the other stations, and also compared to what was originally applied. And this is an example of how important it is also to follow the sediment characteristics both before and after a treatment. So it's important not only to measure water parameters. After we have seen this mobility of the aluminum flock in Lake Nordborg, we decided to look at all the Danish lakes that have been treated with aluminum. And what we saw was that there is a relationship between the lake depth and the amount of recovered aluminium that you find as percentage of the dosed amount. Meaning that the deeper the station is, the more aluminium you will find. Another relationship that we found was that you can find a relationship between the fetch in the lake and the amount of recovered aluminium that you can find at the deepest site. Meaning that the more resuspension you have in the lake, the higher is the risk of having a mobility of the aluminum flock towards the deeper sites. But what is the condition in the lake now in 2013? We have followed the summer saggy depth as an average, and what we see is that we had this improvement in the saggy depth first 2 years after treatment, but thereafter we have a low saggy depth, and in the last 5 years we have actually had 3 years where the summer saggy depth as an average has been even lower than what we saw before treatment. So the aim about a higher saggy depth is not fulfilled. Then there is the phosphorus concentration in the water. There the aim was a concentration below 100 micrograms per liter. That was fulfilled the first years after treatment. But the last 3 to 4 years, the concentration has slowly increased, and now we have concentrations in the lake water of both total P and dissolved inorganic P far above the goal of the 100 micrograms per liter. This increase is primarily due to the external loading, which are still too high and which are still contributing with phosphorus to the lake, and which are slowly building up a new internal P pool in the lake sediment. So the conclusions on this talk is that we saw a successful elimination of the internal P load, and the aluminum treatment worked as we had expected. But we also saw that the lake water phosphorus concentration must be even lower to introduce a significant change in the chlorophyll A concentration. We saw that the aluminum flock can be mobile, especially the fresh flock, as this mobility of the aluminum flock is primarily taking place the first weeks or months after treatment. But we have also seen that the most of the mobile P is also situated at the deeper sites. So maybe it's not that bad that some of the aluminum flock is moved towards the deeper places. And last but not least, it's so important never to forget a sufficient reduction of the external loading. before performing a lake restoration. Because else you will see what we have seen in Lake Nordborg, that after a few years the lake is returning to its former state and a new internal pool of phosphorus will be built up in the sediment and you will continue with a eutrophic status. Thank you very much for listening, and thank you to all the people that has contributed to this study.